Welcome to Exercise Explained. In this video, we would be doing question number 17th and question number 18th. So these would be the last two questions of this particular exercise. All the other questions have been done in the previous video, the link for which will be there in the description below. So starting with the 17th question, a uniform meter rule of mass 100 grams. So by now in all the questions you would have seen that the mass of a meter rule always acts in the center. So I have marked 50 here because 1 meter is 100 centimeter. So at 50 centimeter the mass of the rule is going to act. So that is 100 grams acting at the 50 centimeter mark. Balanced on a fulcrum at mark 40 centimeter. So there is a fulcrum here which is at 40 centimeter. By suspending an unknown mass m at the mark 20 centimeter. So at 20 centimeter there is a mass m which is being suspended here, and we don't know the mass of it, we don't know the exact value of it, but we know that there is a mass which is being placed at the 20 centimeter mark. Find the value of m. So for finding the value of m, since the rule is balanced, we can tell that the anti-clockwise moment will be equal to the clockwise moment. So here to find m, what I would do is the moment of m about this fulcrum is going to be force, that is m, into perpendicular distance that happens to be 20 centimeters, because this is at 40 centimeters and this much we know it as 20. So this much distance is going to be equal to 40 minus 20, that is 20 centimeters. So here I write m into 20 is equal to, this 100 gram is acting at 50 centimeter mark. So we need to find this distance. So this distance, that is the distance between 50 centimeter and 40 centimeter, is going to be 50 minus 40, that is 10 centimeter. So we write it as m into 20 is equal to 100 into 10. So m will be 100 into 10 divided by 20. So that gives me 50 grams. So 100 into 10 divided by 20, 0, 0 cancels and 2 into 50. So here we get it as 50 grams. So the value of m is 50 grams. Now, to which side the rule will tilt if mass m is moved to the mark 10 centimeter? Now if mass m is moved to the mark 10 centimeter, what happens is anti-clockwise moment, that is for m that's going to rotate like this, anti-clockwise moment is going to be, this distance becomes 50 because here it is moved to 10 centimeter here. So if it is moved to 10 centimeter, this was at 40 centimeter. So 40 minus 10 gives me 30. So we take it as 30, and mass is 50 grams. So I write it as 50 into 30, that is 50 here into 30 because m is shifted to the left side. So the distance from the fulcrum happens to be 40 minus 10, that happens to be 30. So we get it as 1500 gram per centimeter. Now what I do is I find the clockwise moment. So clockwise moment is 100 grams into this distance, that is 10. So that is 1000 gram per centimeter. Now as we can see here, the anti-clockwise moment is much greater than the clockwise moment. So the bar will be tilted to the left side. So the bar will be tilted to the left side, or we can tell it will tilt anti-clockwise. So coming to the third part of the question, what is the resultant moment now? Now resultant moment, we will just subtract 1000 from 1500 and write the direction of the bigger moment. So that is, direction will be anti-clockwise because anti-clockwise is greater than the clockwise moment, and the resultant will be 1500 minus this 1000. So 1500 minus 1000, that is 500 gram per centimeter. and this will be in anti-clockwise direction because anti-clockwise moment is more than the clockwise moment. Now, the last part of this question, how can it be balanced by another mass of 50 grams? Now we need to note one thing, that is the left side is already heavier than the right side. So if we add the 50 gram on the left side, it is going to become even more heavier and the rule can never be balanced. So what we have to do is this 50 grams we have to add it to the clockwise side because anti-clockwise is already heavier. So what I would do is sum of anti-clockwise moment is equal to sum of clockwise moment. Now for anti-clockwise what happens is this 50 is at a distance of 40, so 50 is at a distance of 30 from the fulcrum, so that is 50 into 30 is equal to this moment, that is by this 100 grams, so that is 100 into 10 plus, we know the mass as 50 into distance, we take it as x on the right side, so let's assume it is somewhere here. So 50 into x, so this 50 into 30 gives me 1500 and 100 into 10 gives me 1000. 1000 goes to the other side, becomes 1500 minus 1000. So 50x is equal to 1500 minus 1000. So that is 50x is equal to 500 or x is equal to 500 by 50, that happens to be 10 centimeter. So the 50 gram should also be placed at the 50 centimeter mark. Why 50 centimeter? Because it is 10 centimeter to the right of the fulcrum. Now fulcrum is at 40. So 10 centimeter to the right of fulcrum will be 50 centimeter. So that is why it is there at the 50 centimeter mark. Now coming to the last question for this exercise, that is in figure, a uniform bar of length L meter is supported at its end and loaded by a weight W kgf. So W kgf at its middle. So at the middle there is a weight W kgf. The entire length is L. So in equilibrium, find the reactions R1 and R2 at its ends. So since it's equilibrium, so what will happen is both the sides moments will be same. So R1 into perpendicular distance about W, so that's going to be R1 into L by 2 because this is at the center. So if entire length is L, half of it will be L by 2. So we can write R1 into L by 2 is equal to this R2 into again L by 2 because this is at the center, the entire length is L. So this is going to be also L by 2. So R1 into L by 2 is equal to R2 into L by 2. Now we can cancel L by 2 on both sides. So that gives us R1 is equal to R2. So I take it as R. So R1 is equal to R2 is equal to R. I keep that as equation 1. Now, since W is hanging here, what will happen is the reactions will be equal to the action, that is R1 and R2 both are upwards and W is downwards. So R1 plus R2 will be equal to W. So I write R1 plus R2 is equal to W. Now R1 is R from equation 1 and R2 is also R from equation 1. So I get R plus R is equal to W. Now I can write 2R, R plus R is 2R. 2R is equal to W or R is equal to W by 2. So R is nothing but W by 2, that is equal to R1, that is equal to R2. So the reactions are W by 2 each. That is R1 is also W by 2, R2 is also W by 2 since it was exactly at the center. So hope you guys have liked the series of videos for this exercise. We'll catch up in the next video for another chapter. The links for all the videos will be there in the description. Consider sharing the videos with your friends and do subscribe to the channel. Dhanyavad.